Okay, I've gotten quite a few questions on Chapter 10, so I wanted to do a little tutorial to explain some of the types of problems that will be on your Chapter 10 test. Okay, so the first thing is we need to know how to switch from log form to exponential form. So if I have something that is in the form log base b of y is equal to x, if I'm going to switch to exponential form, I'm going to do b to the x is equal to y. Okay, these two equations are equivalent even though they look very different. So in the first example, I have log base 3 of 2x minus 1 equals 4. So if I switch to exponential form, I take the base of the logarithm and I raise to the other side of the equation, 3 to the 4, and I say equals the portion that was left right here. So it equals 2x minus 1. Okay, so I find 3 to the 4th. You can use your calculator. You can say 3 times 3 is 9. 3 times 3 is 9, 9 times 9 is 81, and you can solve. So add the 1 over, so I get 82 is equal to 2x, so x would then be 41. Okay, that is a typical type of question that would be on the non-calculator portion. Now the next one would definitely be on the calculator portion, okay, because we don't know 3 to some power equals 10. That's not something that's easily solved, so we use logarithms to solve it. So I switch from what's called exponential form to log form by doing log base 3 of 10 is equal to 2x plus 7. So you can always check by doing 3 raised to the other side. Yes, that would be 10, right? So you can go backwards. Okay, so if I have log base 3 of 10, some of you guys have a calculator where if you hit the math button and go all the way down, you'll see something that says log base. Okay, but many of you don't. So we do what's called change a base formula. So this is where you can change it to any base that you want. So the base we typically like is base 10. So it's like there's little imaginary 10s in here, right? Log base 10 of 10, log base 10 of 3. Okay, and you could have done it with any base. A lot of times we use natural log as well. So I get 2x plus 7. Oops. Is equal to log 10 over log 3. So now you find log of 10 divided by log of 3 on your calculator, and you should get 2.0959 is equal to 2x plus 7. Now keep that answer that you had in your calculator because you want to be as precise as possible. Okay, so you have that answer in your calculator, and you're going to subtract 7 from it and then divide by 2. And when you do that, you should get x is equal to negative 2.452. Okay, and that would be your answer in the form that I would like to see, like 3 decimals. If I ask for an exact form, which I won't on your test, I like to see the decimal version, but sometimes, you know, like when you go to college, you might have to see an exact form. It would be log base 3 of 10 minus 7 over 2 is equal to x, because you would go straight from this step to subtracting the 7, dividing by 2, and getting that exact answer. All right, so let's try another example. Okay, let's say we have something a little bit harder. So let's say we have 4 to the 5x minus 1 is equal to 8 to the 3x plus 4. Okay, so if we have something like this, you could do the log of both sides and solve and so on. But in this case, we can actually get the same bases. So if you notice 4 and 8, they can both be base 2. So it's going to be 2 to the 2, and then raise to the 5x minus 1 is equal to 2 to the 3 raised to the 3x plus 4. Okay, so this is going to be 2 to the 10x minus 2 is equal to 2 to the 9x plus 12. Okay, and what you have here is you have 2 to one power is equal to 2 to another power. So if I have 2 to some number equals 2 to another number, I mean, those numbers have to be the same thing, right? So I'm going to say 10x minus 2 is equal to 9x plus 12. Okay, and then I solve it just like Algebra 1. So I'm going to subtract the 9x from both sides. So I get x minus 2 is equal to 12. So I get x is equal to 14. Okay. Okay, but I could make this a little bit more difficult, and I could make them so they're not the same base. And this is about as challenging as these questions get. So if I have 3 to the 3x minus 1 equals, I don't know, 4 to the x plus 2. Let's say I have something like that. Okay, these could not be the same base. Okay, so in order to solve it, you could try to like switch forms, or you could just take the log of both sides. The reason we have logarithms is because there's a really cool rule with logarithms. So if you remember from class, it allows you to pull powers to the front. Okay, so I'm going to have 3x minus 1 times log of 3 is equal to x plus 2 times log of 4. And log of 3 and log of 4 are both numbers, so you could multiply those numbers in. Now what I typically like to do is I try to like only have one decimal number that I'm working with. So I will divide my log of 3 over a lot of times, so that I get 3x minus 1 is equal to, and then I'm going to have x plus 2 times log of 3 over log of 4, which is, or log of 4 over log of 3, which is a number. So I'm going to go ahead and find that number on my calculator. So I'm doing log of 4 divided by log of 3. So I get 1.2619. Okay, and you can multiply that number in. Now we like to be as precise as possible though, so you might want to store that number just so you have it. So we get 1.2619x plus 2 times 1.619. So I'm going to store this as a, and I'm going to have 2 times my a. So I get 2.5237 is equal to 3x minus 1. Now it's just like an algebra equation, there's just a lot of decimals. So I'm going to subtract my 1.2619 over. So I'm going to have 3 minus my a value. So I get 1.738 x, and then I have my minus 1 still, equals the 2.5237, which was 2 times a. Okay, so I end up taking my 2 times a, which was the 2.5 number, and I add 1 to it. So I get 3.524, or 37. And then divide by the a value. The 1 point, I guess it was 3 minus a. So you should get x is equal to 2.027. Okay, so rounded to 3 decimals, and that's your answer. Okay, those are about as hard as they get. So when they don't have the same base, that's pretty difficult. Okay, so let's try a couple other. So I kind of mentioned this briefly. I said that we had these rules with logarithms where if I had a power, I could bring it to the front. So let's try one like that. So let's say I have log base 2 of 3x minus 4 raised to the 5th, and it's all equal to 10. Okay, looks pretty daunting. You don't want to take 3x minus 5th, or minus 4 and raise it to the 5th. Okay, but if you remember that you have exponents with logarithms, that they can go to the front. That's the whole reason we created logarithms, to be able to drop exponents. It makes this a little bit easier. So you get 5 times log base 2 of 3x minus 4 is equal to 10. So then I can divide by 5 on both sides. So I get log base 2 of 3x minus 4 is equal to 2. So 2 to the second is equal to 3x minus 4. So I get 4 equals 3x minus 4. So I'm going to get 8 over 3 is equal to x, and that would be your answer. Totally doable without a calculator, not hard. Okay, so likewise we had another rule that if I had log base 8 of x, and then plus log base 8 of 4 equals, I don't know, 3. Let's say we have that. Okay, when I have two logarithms and they're separated by addition, we have a rule that says log of A plus log of B is equal to log of A times B. All right, that's called the product rule. We also have one with subtraction. If I have log of A minus log of B, it's equal to log of A divided by B. And this has to do with the rules, you know, x squared times x to the fifth gives me x to the seventh. Because logarithms are really exponents, okay? So they kind of obey the same rules as exponents. Same with like division. If I had x to the fifth over x squared, I subtract my exponents and I get x cubed. Okay, so division is related to subtraction, addition is related to multiplication. So when I see log base 8 of x plus log base 8 of 4, I combine into 1, and I say it's log base 8 of 4 times x, so 4x is equal to 3. Okay, so I'm going to have 8 to some power, 3 is equal to 4x, right? 8 to the 3 is equal to 4x, so all you do is switch forms. So 8 to the 3, that's not probably one I would ask you on your non-calculator, but you can easily find it off to the side if you need to. It's 512, or you can use your calculator, equals 4x. So when you divide by 4, you get x is equal to 128. Okay, so your answer would be 128. So let's try a division one as well. So let's say, I forget what number that was, I think it was 6, it's number 7. So let's say I have log base 3 of x plus 2 minus log base 3 of 2x plus 1 equals 2. Okay. When I have my two separate logarithms, I combine into one logarithm, so I just write log once, and I do it with division. X plus 2 divided by 2x plus 1 is equal to 2. Okay, then I switch forms. Okay, so I have 3 to the 2 is equal to x plus 2 over 2x plus 1. Okay, 3 to the 2 is 9, so I get 9 is equal to x plus 2 over 2x plus 1. And I'm going to think of 9 as 9 over 1, and I'm going to cross multiply. So I'm going to multiply these two together, and I'm going to set it equal to these two. Basically what I'm doing is I'm taking the denominator and I'm multiplying it to the other side. Same thing. So I get 9 times 2x plus 1 is equal to 1 times x plus 2. So 18x plus 9 is equal to x plus 2. So 17x plus 9 is equal to 2. So negative 7 when I subtract the 9 over. So 17x equals negative 7. So that means x is equal to negative 7 divided by 17. Okay, that's pretty much, you know, the basics of logarithms. There aren't that many other types of problems that you might have. I'm trying to think of any other strange ones. I mean, you did have one on your homework that involved like 1/2. I don't remember exactly what it was, but maybe you have something like this. And you could do it the way I did that one difficult problem where you took the log of both sides. But really the key to this is noticing that 8 can be written as 2 cubed. And 1/2 can actually be written as 2 to the negative 1. So if you're good with your negative exponents, I think you'd notice that. But it's okay if you didn't, you could always do it without that. So then you'd have 2 to the negative 2x plus 3 is equal to 2 to the 3x minus 3. And then you set your two powers equal to each other, because you have 2 to a number equals 2 to a number. So negative 2x plus 3 is equal to 3x minus 3. So you get 5x equals 6, so x equals 6/5. And that's your solution. Okay, other things that you might have would be involving natural log in e. So let me give an example of that. So let's say I have natural log of 3x minus 1 is equal to 6, okay? Natural log is really just a fancy logarithm, right? It's really just log base e. That's all it is. So whenever you see natural log, if you replace with log base e, it might make more sense to you, right? So when you do that, you can see, oh wait, now I have a base. My base is e. So I have e to the 6 is equal to 3x minus 1, and you can solve. So e to the 6th, don't worry, that would be a calculator question. You do the e button, which is on the ln key, so do second ln, and you get e to the 6th. So you get 403.429, and I leave that number in my calculator. So then I add 1 to it, and I divide by 3. So you get x is equal to 134.8. It's 0.95, so I'm going to round up to 10. And I'm going to put that 0 to indicate that I did round to 3 decimal places. Okay. You might also have something that has e raised to a power. So let's say I have e raised to the 2x minus 1 is equal to 5. Okay, these ones aren't bad at all. You can switch forms, right? You can think of it as log base e of 5 equals 2x minus 1, right? So you can see that this is now natural log, okay? Or you can remember your log rules. Now, back in the very beginning of the chapter, I showed you guys that if you have like log base 8 of 8 to the 7, you can think of the 7 going to the front, and then log base 8 of 8 is 1. It goes away, right? So same thing here. If you have an e and a natural log next to each other, right, which is log base e, they go away. So what you can do is you can do natural log of both sides to get rid of the e. So that way you have 2x minus 1, because it's going to the front, and the natural log e cancels, equals ln 5. So if you were writing the exact form, it'd be ln 5 plus 1 divided by 2. But I like to see the decimal version, so let's go ahead and find it. So I'm going to have natural log of 5 plus 1 divided by 2. And I get 1.305, and that's your answer. Okay, and you did have some really tricky ones. So let's say, you have, so this is kind of like a story problem one. Let's say you have a substance and its half-life is 1,000 years. Okay, and then after a certain amount of time, you have, 20% left. So how many years have passed? Okay, so if you set up the half-life problems, I told you guys that there's a part 1 and a part 2. The part 1 can be simplified if you do remember this formula. The natural log of 1/2 divided by h is equal to r. So if you memorize that, you're golden, because you can kind of skip this part 1. If not, you kind of have to work it out. So let's say you didn't memorize, okay? But you started out with a certain amount of the substance, and this is a continuous decay. Remember we talked about if you have an object that's decaying, it's not going to be like, okay, in 1 year I'm going to just decay a little bit, and then I'm going to wait, and then the next year I'm going to decay a little bit more. It's continuously decaying. So if I start with P, then after a certain number of years, right, after 1,000 years, I end up getting half of what I started with, P. So really it didn't matter that you had P here. You could have started with whatever amount you wanted, like 100 grams or whatever, and it would go away. So you get 1/2 is equal to e to the 1,000 r. So then you take the natural log of both sides. And the natural log of e and the e cancel. That's why we do that. So we end up getting the natural log of 1/2 divided by 1,000 is equal to r, which was that formula that I told you. If you memorize, you'll be good. So you got natural log of 1/2 divided by 1,000. Now I would find that on my calculator. So natural log of 1/2 divide by 1,000, and you get negative 6.93, and it's in exponential, well, scientific notation, so times 10 raised to the negative 4. That's what that e thing means on your calculator, like it's a e. So mine says 6.93 blah 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 blah, and then it has e negative 4. What that really means is times 10 raised to the negative 4. Okay, so that's my rate. Now what I typically do is I store this value. So I would hit stow, and I'd store it as a. So that way it's in there, I'll have the exact rate when I need it. So the question said, only 20% is left. So how many years have passed? Okay, so if I start with P, I'm going to have that rate, which I have stored as A. So I'm going to go ahead and indicate that I've stored it as A. So I'm going to write an A next to it. Okay, and instead of writing all that out, I'm just going to put A, because I stored it as A, so it's in there, we're good. Okay, and then to the T, and I'm going to be left with 20% of what I started with, because it said 20% of the initial amount remains. Okay, so I'm going to divide by P, so I get 0.20 equals E to the A times T, and it looks like you have 3 variables. It looks like you have E, A, and T, but A is a number, E is the number, 2.718, goes on forever, right? T is the only thing that we don't know, so that's what we need to solve for. So I do natural log on both sides. Natural log and E cancel. So I get the natural log of 0.20 divided by that value I just stored in my calculator, A. So I'm going to do natural log of 0.2 divided by A. So I get T is equal to 2,321.928 years. And that's your answer. Okay, and then we also had some finance problems, so we'll do a couple of those. Okay, so on these problems, I don't know what my numbers are. Okay, so let's say that Caitlin has a checking account and she puts in $2,000 and it's compounded monthly at 3%. How much will she have in 5 years? Okay, so this is one of the problems with the A of t is equal to P times 1 plus R over N to the NT. So basically the bank is trying to trick you, and instead of giving you 3% every single month, they divide it into the 12 months and give you less of a rate. Okay, so you have $2,000 that you invested. That's your P. So I'll kind of label P. Your rate is 3, but you write it as 0.03. So don't mess that up. It's 3%, 3 per 100. So how much will she have in 5 years? So T is equal to 5. So I have times 1 plus my R is 0.03 divided by 12. So I guess I forgot that. Monthly, right? So number of times each year would be 12. And then it's raised to the n times t. So the nt ends up being the total number of times it's compounded. So 12 times for 5 years. So 12 times a year for 5 years would be 60. So we're going to do 12 times 5. Now I put that in parentheses. So it's not 12.5, but 12 times 5. So maybe I'll make a little, like a star. Okay, and then you put that all into your calculator. You can do it all at once. Okay, as long as you have parentheses around that last 12 times 5, you'll be good. But you could easily say that that's 60, right, in your head. So you end up getting $2,323.23. And that's your answer. Okay, but a lot of times I like to ask part B on this. So let's say I have a part B to the problem. and I say, how long will it take for that amount of money to double? So if I start with $2,000, how long will it take for me to reach $4,000? Or Caitlin. Okay, so we're going to figure it out. So I'm going to have raised to the 12 times t. We don't know how many years it's going to be invested. Okay, so I divide by 2,000 on both sides. So I get 2 is equal to 1 plus, I have my 0.03 divided by 12. So I get 0.0025. And sometimes this number isn't nice, so you would just like store it or keep it in your calculator. Raise to the 12th t. Okay. Now at this point I can switch to logarithmic form. Like I could always do log, my base was 1.0025 of 2 is equal to 12t. So you can switch. Okay. Or you can just take like natural log of both sides or log of both sides, it doesn't matter. So I always said when in doubt, switch. So a lot of you guys are probably going to do this way, which is fine. So you would then write in your log form, or with your change of base formula. So that's the change of base formula. So you'd get that. Okay, so now you're at the point where you need to figure out what log of 2 over log of 1.0025 is. So log of 2 divided by log of 1.0025. So make sure you're checking along with me. You should get 277.605 equals 12t. So then divide by 12. So it would take her 23 years to double her investment. A long time.